Hi, friends, and welcome back to Technology Now, a weekly show from Hewlett Packard Enterprise where we take what's happening in the world and explore how it's changing the way organizations are using technology. We're your hosts, Aubrey Lovell
and Michael Bird. Now, in this episode, we are taking a trip high above the Earth and looking at how we are storing our data in space. We'll look at the continued evolution of data storage technology in microgravity. We'll be examining the unusual challenges that come with storing information in Earth's outer atmosphere, and we'll be asking why it matters to our organizations.
Michael, that is so far out, no pun. And if you're the kind of person who needs to know why what's going on in the world matters to your organization, this podcast is for you. And if you haven't yet, subscribe to your podcast app of choice so you don't miss out. All right, Michael, let's get into it.
Yeah, let's do it.
We know that space is tough on humans, but it's also tough on our technology. Our bodies weren't built for the harsh conditions of space, and neither were most of our everyday digital storage devices. The average solid-state drive functions best within a temperature range of minus 40 degrees Celsius to over 85 degrees Celsius. So that's roughly about negative 40 to 185 degrees Fahrenheit. But the temperatures in space could range from close to absolute zero to over 120 degrees Celsius, and that's about 240 degrees Fahrenheit. And then you have the issue of cosmic rays, which are energetic particles from outer space that travel across the universe and cause havoc within our tech.
They do this in several ways, but the most common is by triggering bit flips, which is when the transistors that underpin our binary computer systems get hit by a particle and switch state, which is not ideal for data storage. Now, we've talked about the Spaceborne Computer 2 on the podcast before, an AI-optimized supercomputer built in partnership with HPE on board the International Space Station, and we'll link to that episode in the show notes. It's an incredible piece of tech, but how do we store all the data associated with it safely? Well, to break it down, I recently met with Tyler Nelson, director of KIOXIA's Innovation Lab and Technical Marketing Team. His company is a leader in flash memory technology and provides data storage solutions aboard the International Space Station. Tyler, welcome to the show. So can you just give a real brief summary what the Spaceborne Computer Program is and why it's so cool?
Sure. So the Spaceborne Computer Program was originally designed to showcase that off-the-shelf commercial computers could be used in space. Most of the computers that are in space today take many years to develop. It's like 3 nodes with a quorum, and it takes 10 years to develop it for a specific thing, whether it's guidance or whatever. That takes a long time to get those built, and by the time they're actually shipped to space, they're 10 years out of date, right?
Yeah.
So if you want to do modern workloads, you want to do AI, you want to do GPU-based compute, image analysis, DNA sequencing, those are all projects we do on Spaceborne today. You need modern GPUs and a modern computer system, but you don't have the time or the money to develop a complicated system. So NASA asked HPE to find a way to send up standard commercial equipment to handle these type of workloads instead of developing something custom.
Yeah. Wow. But KIOXIA provide the storage. Can you just talk through how that whole thing came about, the challenges that you had to overcome? Yeah, just a bit more detail about the whole project.
So originally we sent up some SATA drives. We no longer make SATA drives. As part of that, there were some challenges around those drives. We now have our NVMe SSDs up there, but some of the challenges are around power. So we have our RM value SAS drives, which have a peak of 9 watts. So that keeps it under the power envelope, allowing us to run the GPUs in space and sort of enabling all of the fun things that we get to do on the research projects.
So let me just rewind it back then. So you were contacted by HPE and they said, we need some more storage, different storage in our Spaceborne computer. Tyler, can you sort us out?
Something like that.
Okay.
The original Spaceborne computer went up several years ago, and I was actually not involved in the original Spaceborne program. However, we've figured out we had some challenges with the original SSDs, and they were looking for something a little more robust, but it needed to meet all the requirements. Again, they want off the shelf, right? The whole idea of Spaceborne is off the shelf components. We don't want to custom build some special magic SSD shielded from radiation. We need to be able to meet the challenges of space with standard commercial equipment. So they asked us to provide drives. We sorted through what their requirements were, how much storage they needed, and we ended up adding our 30 terabyte high performance SAS SSDs as well. So we have 120 terabytes of storage on the Spaceborne. Yeah, no, it's
a lot of storage.
It's a lot of storage. But they're doing GPU compute, they're doing video, they're doing image analysis, video analysis.
Yeah.
To do that takes a lot of storage to store all these projects. And we can't transfer all the data back and forth. It's a very low bandwidth link. So we have to store all of those things in space, do our processing there.
But it's a slow connection.
Yes. It used to take 5 days to download the images for glove analysis. We do that with a container running an AI image analysis. We do that in 45 seconds.
Okay. So having tons of storage on the International Space Station is super useful. You can do loads of stuff with it. Now, you said the whole Spaceborne Computer 2 is completely off the shelf, including the storage.
Absolutely.
So I could go to a shop and I could go and buy the same storage that's being used on the International Space Station.
Absolutely.
Wow, what a badge. Do you have that? Do you have that on them? On the boxes? Does it say as seen on the International Space Station?
No, but we should. That would be excellent branding. As seen on the ISS. That would be excellent. No, it's a standard DL360 and an Edgeline system with standard off-the-shelf RM, PM, and XG8 drives that are up there.
So in space, there's the sort of challenges with regards to, I don't want to use the wrong word, but it's the sort of cosmic rays causing problems. Can you just sort of explain what the challenge of having storage in space is? Like, you said there's the old process was it would take 10 years to sort of make sure it will work in space. Why is that?
Partly, the original design from NASA, they would design each computer system for a specific thing, whether it's guidance or life support. Those are critical systems. So the projects we're doing are not life support for astronauts, right? They're very useful experiments, and there are a lot of interesting things that we can do, but it's not critical as far as like keeping astronauts alive. So that's why we can get away with it. And if something fails, we've learned, okay, we understand what failed. In the initial SSDs, it was a supercap, right? And we had several of those fail. We don't use the same type of supercap anymore. So we understand what fails, and then in the next generation, okay, we can solve those little problems. Long term, it's to do computing for the moon or for Mars, right? There's no way you could download the data from the moon to do analysis on Earth.
Yeah.
You need to be able to send that computing power with astronauts when they go to the moon, when they go to Mars in the future.
Yeah, okay. But there's this concept of, I think it's bit flips.
Absolutely.
So what is that? Why is it so annoying?
So a 1 turns to a 0, and the whole sequence is, it changes from a 7 to a 4 or something.
And that's caused by?
That can be caused by radiation or by cosmic rays, either one.
Which aren't common, or you just don't get at all on Earth?
We're protected by our atmosphere.
Right.
So cosmic rays can still cause problems on Earth. Radiation from the sun does not cause nearly as many problems as it does in space, because there's no protection there from the radiation from the sun. We had problems with the aurora borealis, where we had 4 different bit flips within the L2 cache of the CPU. None impacted the storage, which is great for me. I'm like, yeah, all right. Our stuff works great. But the L2 cache on the CPU was impacted by the radiation from solar flares that had the aurora borealis, I believe, May 10th, 10th through 12th.
Wow, okay. So it's quite a hostile environment to be bringing off-the-shelf hardware into.
Right.
So how are you combating that? Is it clever software, clever hardware, lots and lots of redundant hardware, lots of redundant hardware and clever software, a combination of the 3?
A little bit of a combination of the 3. The software is redundant. We do have 2 separate Spaceborne computer nodes up there, each with 2 servers. And then within that, we have multiple drives and RAID sets to handle the redundancy in case there's a problem with a drive or a problem with a server, so that we can handle any kind of cosmic rays that might come about.
So if there is another Spaceborne computer, would you make changes for next time? And what have you learned from the Spaceborne Computer 2 project?
We are looking at new form factors. We would really like to send our E3S drives up, which have our heatsink directly on top, which would make it easier to work with the plates and the cooling that we're looking to do for the lunar Spaceborne. So the plan is to send a lunar rover up, and we're going to have 2 more Spaceborne computers on the lunar rover.
Wow, that is really cool.
Amazing insights from Tyler there, and I can't wait to hear the rest of the conversation.
All right, well, now it is time for Today I Learned, the part of the show where we take a look at something happening in the world that we think you should know about. Now, Aubrey, I think it's one from you.
Yes, indeed, Michael. And we're staying on Earth for this one, so no need for a spacesuit. A team of European scientists in Antarctica have pulled some of the world's oldest bubbles out of the ground. Over the course of several summers, the team extracted a single 2.8 kilometer or 1.7 mile long tube of ice from the ground, at the bottom of which lie bubbles of air trapped over 1.2 million years ago. Now, the tube really is a story of the Earth. Visible within the ice are ash from volcanic eruptions and telltale signs of great geological changes in our planet. It's hoped that the research, which involved scientists from 10 European nations working in temperatures of negative 35 degrees Celsius or negative 31 degrees Fahrenheit, will help reveal some of the major mysteries in our planet's climate history. And that includes what happened over 900,000 to 1.2 million years ago when something disrupted global glacial cycles, driving our ancient ancestors to the brink of extinction. Pretty awesome and pretty interesting.
Yeah, pretty awesome and pretty interesting. Thank you, Aubrey. Right, well, now it is time to return to our guest, Tyler Nelson, director of KIOXIA's Innovation Lab, to talk about the future of data storage on the International Space Station. So, Tyler, what's next for the Spaceborne project? So we've done Spaceborne Computer 1, Spaceborne Computer 2. What's next?
What's next is Spaceborne Lunar.
That's pretty cool. It's a cool name.
It's going to be very fun. There will be a rover that we're sending to the moon shortly. And on that, the plan of record is to have an additional Spaceborne computer on that so we can test commercial off-the-shelf hardware on the moon.
Being on the moon, does that have different challenges to being on the International Space Station? Because the International Space Station is low Earth orbit. Is it protected by a bit of the atmosphere? What's the lunar atmosphere like? What are the challenges around that?
So the ISS has shielding within the ISS modules, obviously, to protect the astronauts. And it is in low Earth orbit, so it does have a little protection from the atmosphere. The moon, we won't have any of that. So there will be some additional challenges.
Even more challenging.
It will be even more challenging. So we'll have to see how it works. We're working on the hardware, but we don't want to give it too much shielding. We don't want to give it too much because that will stop us from learning from all of the realities of the environment.
Yeah, okay. And this will also be off-the-shelf equipment?
Yes, off the shelf.
So you'll be able to go out and buy the same equipment that is potentially going to be on the lunar surface?
That's the whole idea. It should be an HPE Edgeline 8000.
Wow, that is fascinating. So what is storage technology going to be looking like in 10 years' time? Are we still going to have a tape, spinning disk, SSDs? Will they all be a distant memory? Will they all still be around?
Well, unless there's some new memory technology that comes around, I'm pretty sure we'll still be using SSDs.
Yeah.
What number of bits we store per cell may vary by quite a bit. We're still using tape today, so I don't know that tape will ever go away. It's just, it is what it is. But we have new technologies around SSDs as far as form factors, performance. The speed of the SSDs keeps going up. We've quadrupled it in the last 5 years. So SSDs are now up to 14 gigabytes a second. PCIe 6 comes out. Okay, now we're 30 gigabytes a second, almost 28 gigabytes a second. Then what happens with PCIe 7? Long term, we're going to have to feed all these GPUs, run these AI projects. Storage is just going to get faster and faster.
Yeah, it feels like it's a bit of a whack-a-mole within the insides of a computer as to like what bit is going to be slowing it down. Is it the CPU? Is it the storage? Is it the memory? Like, is it the interconnects between them? Is it the PCIe lanes? Like,
well, for a long time, it was the hard drives.
Yeah.
It really was. And so a lot of software has been written to not write to storage, to try to use memory as much as possible and only write to storage when it has to. And now we're reworking software where storage layers can interact directly with GPUs through GPU Direct or other things like that. So we're increasing the performance of the storage, which allows increased performance of the GPUs as well.
Yeah, amazing. All right, final question. Why should our audiences care about the advances in storage technology?
It can make your servers much more efficient. Obviously, it's in our phones. It's in our everything your smart televisions. There's flash in there. That's what it boots off of. So as this gets faster and faster, your storage can be more efficient, take less power. Everything's really targeted at efficiency, but also enabling workloads of the future. If the storage is fast enough, then your CPU can actually do your AI compute and learn from the data or do training or all the different fun things that we're working towards for the future. So
amazing. Tyler, thank you so much for your time. Really enjoyed having you on this episode of Technology Now.
Thanks so much, Michael. And thank you to Tyler for the interview. That was really insightful. And you can find more on the topics discussed in today's episode in the show notes. So we're getting towards the end of the show, which means it's time for This Week in History, a look at monumental events in the world of business and technology, which has changed our lives. Michael, what do we have today?
The clue last week was it's 1902 and this innovation sucked. Aubrey, I think last week you and we thought maybe it was something to do with vacuum cleaners.
We did. I think we were kind of oscillating around a vacuum type invention.
Yes.
For sure.
And you were correct because it was the invention of the first powered vacuum cleaner by Londoner Hubert Cecil Booth. Great name. But like most early prototypes, it wasn't exactly compact. The vacuum took 2 people to operate, one to wield the large nozzle, and the other to manhandle the refrigerator-sized machine, which, by the way, had a petrol engine. Wow, that must have been... you've sort of been vacuuming fumes at the same time as the fumes are being generated. Exactly. I assume the exhaust goes out of the building. You
would hope so, because you'd be cleaning and your house would just be filled with gas. The gas smell. Not so clean, right?
Yeah, anyway, that said, it did have some high-profile success being used to clean the coronation carpet under the throne at Westminster Abbey for the coronation of Edward VI in 1902. So there we go.
That's amazing. Thank you, Michael. And the clue for next week, it's 1949, and this global trip was a real high flyer. Huh. Any ideas, Michael?
Global trip, 1949. Something, definitely aircraft, isn't it? Airplane, maybe first round trip, maybe first high altitude round trip or something. 49, that's about right, isn't it? So I'm going to go something like that.
Got it. Yeah, that sounds about right, but we'll have to see and wait till next time. Yes. And that brings us to the end of Technology Now for this week. Thanks again to our guest, Tyler Nelson, director of KIOXIA's Innovation Lab and Technical Marketing Team. And to you, our listeners, thanks so much for joining us.
Technology Now is hosted by Aubrey Lovell and myself, Michael Bird. And this episode was produced by Sam Dattapoulin and Lincoln Funder Vesthazen, with production support from Harry Morton, Zoe Anderson, Alicia Kempson-Taylor, Alison Paisley, and Alyssa Mitri.
Our social editorial team is Rebecca Wissinger, Judy Ann Goldman, Katie Guarino, and our social media designers are Alejandra Garcia and Ambar Maldonado.
Technology Now is a Lower Street production for Hewlett Packard Enterprise. We'll see you at the same time, the same place next week. Cheers.